Hello, this is Mr. Stansbury. I'm going to take you through the notes on expectation. At the end of this, you should be able to say, I can find the expected value of various random variables. Okay, so first thing, expected value. The expected value is the average value of all the events. Okay, probably the easiest way to understand that is to show you an example. We have a spinner over here, and it looks like all the sections are equally likely to occur. So each one's got the same probability. There's 6 sections, so each one of these sections has got a 1/6 probability of being spun. Okay, so for example, when the spinner is spun, players are awarded the resulting number of points. On average, how many points can we expect to be awarded per spin? Okay, so here's how this works out. There's 6 different outcomes, right? We can get 1, 1, or 1 here. 2, 3, or 7. So all the 6 different possible outcomes are 1, 1, 1, 2, 3, and 7. Since those are all equally likely to happen, we can simply add those all up to get 15 and divide by the total number of outcomes there are, which is 6. There's the total possible things that we could end up on. So we take our 15 divided by 6 and we get 2.5. So an average of 2.5 points per spin. This here is the expected outcome. Oh, expected value. Sorry, not outcome. Expected value. Okay, so per spin. All right. Now, another way to look at that is another way we could have calculated that is say, okay, we've got 4 different possible outcomes. We've got 1, 2, 3, and 7. What's the probability that we'll spin a 1? 3 of the 6, which is 1/2. 3 over 6 is 1/2. 3 over the 6 will give us a 1. So there's our 3, 6, which is 1/2. So here's our probability times the value. Plus, there's only 1 of the 6 is going to give us a value of 2. So 1/6 times 2, 1/6 times 3, because there's only 1 of the 6 spaces are 3, and then 1/6 times 7 as well would give us 15 over 6, which also gives us 2.5, which is the expected value. So that's a different way to look at that. Okay. The reason why I'm showing you this here is because there's a lovely formula this here is going to help us understand what this formula means here. So this can be described as, for a random variable x with possible values x1, x2, x3, x to the n. So these are the possible outcomes. So in this case here, like 1, 2, 3, and 7 are 4 possible outcomes, and associated probabilities, right? So the probability of spinning a 1, that we figured out, that's 1/2. Probability of spinning a 2 is 1/6. A 3 is 1/6, and the 7 is 1/6. Okay, so and associated probabilities. The expected value of x would be given by this formula here, which again we actually just did right up here. Okay, so this means starting with 1. So the value, of the 1 here, we value for this 1 spin is 1, and then times the probability. So that's 1 times 1/2, which is what we did right here, and then 2 would be the next value that we'd have. So the 2 is the value, and the probability of 2 is going to be 1/6. So there's 2 times 1/6. So really, these are just flipped around from what this is. What I did up here is we officially did the probability of I times x sub I. Okay, so but it's the same thing because you're multiplying. Okay, and that's going to give us all of these things here, which is what this is showing here, and then you add those all up, and that gives you your expected value, which was 2.5. Okay, E of x is the mean of the probability distribution of x. So it's the average, okay, which hopefully that makes sense. That's what we're finding. We're finding the average number that comes out, okay? And it's also sometimes denoted with this Greek symbol here, which is mu, okay? Okay, let's move on to some more stuff here. From our last set of notes here, we had these lovely albums here. So from example 2 on the previous section of notes, record store recently had a sale on some hot new releases. 7% purchased all 4, 16% purchased 3 of them, 21% purchased 2, 24% purchased 1, and 32% purchased none of them. Let X be the number of albums sold to a randomly selected customer. For this one here, we're going to find the expected number of sale albums bought by each customer. And then what does this represent? So let's figure out the possible sale. Let's find the expected number of sale albums bought by each customer. So to do that, we would simply take our expected value. So, let's see here. Sorry, we got our expected value of 4. How many people are going to buy 4? That was 7%, 0.07, plus, and then the number of people that purchased 3, and the probability of that was 16, 0.16. Number of people that purchased 2 was 21% times 0.21. Number of people that purchased 1 was 24%, 0.24. And then 0 purchased 0.32, right? And so we're going to add those all up, and that will tell us the expected number of sale albums. Okay? Okay, so I went through and calculated all of those out here. So this was 0.28, 0.28, 0.48, 0.42, and 0.24. 42 plus 0.24, and of course 0 times anything is going to give us 0. So when we add those all up, and it gives us 1.42. So 1.42 is our expected number of sale albums bought by each customer. What does this represent? So basically, the store owner can expect that every person that comes in to buy records, on average, they're going to buy about 1.5 records. Obviously, they're not going to buy a half record, but on average, 1.42. So if they had 100 people come in, they could expect to sell 142 of these fantastic albums here. Okay? Okay. Let's see. One last thing to go through, but before we do that, let's take a quick comedy break.
There's 2 reasons I don't like body wash. 1, when I get out the shower, it feel like it's still on me. 2, it uses words that I can't readily identify with, such as exfoliation. That don't even sound positive. Why are we doing that to ourselves? Sounds like something you lose friends over to me. I can hear the conversation now. You know, me and Mike was cool. We grew up together. We was like this, but ever since the exfoliation. He not the same dude no more. It's because I'm moist. That's why I'm against my will.
Okay. Fair games. Expected gain. The expected return or payout from a game less the amount it is to play is what the expected gain is. Okay. So the expected return from a $1 slot machine is 0.971. So that means the expected gain is figure out how much you're going to get back from it, 0.971, minus the amount it is to play. So 0.971 minus 1 means that on average, you are expected to lose about 3 cents every time you play the $1 slot machine. Okay, that's how Vegas and all the gambling places make their money, because the expected gain is always going to favor the house or the casinos. Okay. Now, a fair game is where the expected gain is 0. Okay. E of x equals 0, where x is the expected gain. Okay, that should hopefully make some sense here. Oops, and let's take a look at our last example here. So let's say in an American roulette game, you will get your bet doubled if you guess the right color, which is pretty standard, I believe, for most of the casinos and whatnot. So A, find the expected return if you bet $5 on black. Okay, so if we look on here, I'm just going to tell you how many of each of the spaces there are. Okay, so going through and counting, there are 18 black spaces, 18 red spaces, and 2 green spaces. Okay, so find the expected return if you bet $5 on black. Okay, so these three all added together, 18 plus 18 plus 2 is 38 possible outcomes. How many of those are going to give us, are we going to win with? That is going to be 18 out of the 38, right? Which gives us a little bit less than a 50% chance of winning. Okay, so if we get one of those 18 out of the 38, our expected payout is $10, right? So if we go through and we calculate that there, we get 18 divided by 38 equals 0.47, and then we multiply that by 10. The expected payout for each one of these is $4, and let's round it to $4.74. $4.74. Okay, but then again, you got to take your remember, our formula there is your expected payout minus what it costs to pay. So so part B, here's the expected return, $4.74. Part B says find the expected gain if you bet $5 on black. So your expected payout, your expected return is $4.74, but we got to subtract the $5 that it costs to pay. So that gives us a net gain of negative point, what, 220. We're going to lose 26 cents every time we bet $5 on black, if we bet for a whole bunch of times and let all the probabilities catch back up to us. Okay, so the expected gain is that you would lose 26 cents. Okay, would you recommend playing this game? Probably not, because again, you're going to end up losing. You want to find the game that has the highest expected gain. Expected return doesn't really mean a whole bunch, because it all depends on how much you have to pay to play it. So you want to find the game that has the highest expected gain. So would you recommend playing this game? No, because on average you'd lose 26 cents every time you play it. Okay, French roulette is the same setup without the double zero. How does this affect the expected gain for this game? So if we were to recalculate this without the double zero, then black would still be 18, red would still be 18, and green now is just 1. Okay, so that would be 18 plus 18 plus 1 is going to give us 37 possible outcomes. So now it would be 18 out of 37. Right, which gives us 18 divided by 37 gives us 0.4. Let's see, 0.4864, and then let's see. So let's do this times. So sorry, we'd take that times 10, right? So then multiply this by 10, and we'll round it to the nearest penny. We get our payout. Expected payout is $4.86. $4.86. So our expected gain would be 4.86 minus 5.00, which is negative 14 cents is your expected gain on that game instead. Okay, so it's a little bit better, but still not fantastic, I suppose. Okay, all right. That is all we have for expectation. If you have any further questions, please feel free to ask. Thanks.